Hello and welcome. EDS stands for Early Detection System. The following video demonstrates some of the benefits of an EDS over a traditional SCADA system. It presents 10 water quality cases which a standard, SCADA-based control system will not identify, while an EDS will identify and alert. Each of these cases requires human attention. Some are equipment malfunctions, while others are symptoms of problems that can aggravate without proper treatment and necessitate interruption of the water supply. In this video, we will bring up the question, why EDS? Case 1, Single Sensor Short Deviation. Our first example is a turbidity sensor that reports a short-term change in its measured value. As you can see from Figure 1, the chlorine measurement at the station does not change much. Also, the width of the abnormal signal of the turbidity is about an hour long. This hints for a small amount of organic material that may have penetrated the water system. In many cases, this is a symptom of sand intrusion to the water system due to small cracks in pipes. This signal indicates that this is not an electrical problem. In most cases, this signal is a result of a small amount of dirt at the measuring chamber. There was no violation of user limits, which indicates that the amount of affecting substance is low. Case 2, Communication Problem. The second example is a communication problem. A coordinated drop of several sensors sharply from a standard value to a zero value indicates a communication problem. Distributed water systems often transmit their data using a cellular network. Cellular communication malfunction can cause several sensors to display a zero value for a while. The problem usually resolves within a few minutes, and the sensors return to normal. It is quite clear that it is not possible to make a change in the composition of the water, so only a communication fault can explain such a situation. Case 3, Fixed Value. The third example is a fixed value. In water systems, which measure flow, day and night temperature change and air penetration affect the quality of the measurement, so a constant quality value is rare. When this happens, the cause is usually a sensor malfunction or incorrect definition of data processing. The EDS system is typically able to learn what is the typical period in which a fixed value appears. Beyond this time, an alert should come up. Case 4, Sensors Maintenance. The fourth example is maintenance activities. Water sensors require periodic maintenance activities. The event involves a short period, usually of less than an hour, during which the sensors are being cleaned. When this happens, the value of the sensors quickly changes from one endpoint to the other. The EDS system is usually supposed to detect such a situation and not create a false alert. Case 5, Abnormal Jump. The fifth example is a coordinated jump to a high-level value and a return to normal of some sensors measurement. This condition is usually caused by electrical interference with several sensors fed by the same voltage source. Sometimes the sensors all go to a maximum value, and sometimes each one reaches a different level on the scale. Case 6, Change in baseline, pattern and noise. The sixth example is 3 changes that co-occur. The first is a change in baseline. The graph shows an array ranging from 0.3 to 0.4, and the system moves to an average of close to 0.7. Surprisingly, both the decrease in the amount of noise and the pattern of the graph is still noticeable. This decrease can be caused, for example, by a change of a pump inlet that controls the line pressure, or a change in the water sampling somewhere from the line center to the point of measurement. Sometimes, a change in the control system or a malfunction of the equipment can be the cause of this. Case 7, Effect of physical measurement on quality measurements. The seventh example is the physical measurements effect on quality measurements. In the graph shown, the green line indicates noise measurement in physical variables. For example, pressure or flow. The blue line indicates noise in quality variables. You can see from the graph that noise in quality variables appears many times after noise in physical variables. In this case, there is no need to create an alert because it is a false alert. Case 8, constant drifted. The eighth example is the drift of the measurement value. You can see that the green line, in this case, chlorine measurement, is gradually rising within a few weeks. The reason for this behavior can be environmental changes, for example, temperature. But in many cases, this is an indication of a gradual departure from the calibration of the sensor. Case 9, deterioration of quality. The ninth is a gradual decline in water quality. It is customary in the EDS system to assess the overall quality of the water. Optimal water is water where each of the quality values is at the optimal value. In this case, it is customary to give water a quality value 1. As you move away from the optimum measurements, the water quality index moves away from a value of 1. The attached graph shows a gradual decrease in the water quality indicated by the green line over several months. Case 10, spatial limits. The last and 10th case is about spatial boundaries. Spatial boundaries are the boundary at which to expect measurement at a destination station. The expectation is based on tested measurements of the same water in an earlier and coordinated time. In the example above, we can see a sample of conductivity. A 300 micro-Siemens conductivity value at one station could not change substantially within 3 to 4 kilometers at a destination station, unless something or someone tampered with the water. Any deviation from the boundaries indicates that something happened to the water in the passage between the stations. The 10 cases presented to us show quality issues that need attention from the water network manager. Of course, such problems can be ignored since none of them indicate deliberate poisoning of the water. But addressing these issues will allow you to identify the actual issues when they appear and take care of them before they become a crisis. As explained at the beginning of the document, such issues are detectable by the EDS system but are not detectable by the SCADA system. This difference hence shows the benefits of installing an EDS system alongside the SCADA system.